Here is Anmol Saxena from BSc second year, roll number 215037. Today I am going to discuss about the topic SHM, which is simple harmonic motion. So firstly we will discuss about the definition of SHM, the kind of motion in which a particle moves in a straight line in such way that its acceleration is always toward a fixed point on the line and varies as distance of the particle from the fixed point is called simple harmonic motion. So in simple harmonic motion, acceleration is directly proportional to the distance of particle from the fixed point. So from this figure we can see that there is a mid position O, and as like the pendulum, its main position is this, and it will go like A here and here A, to and fro motion. Okay, so here from O there are two cases. It will go from O to A and then O to A dash. The distance between these 2 points are identical, which is A and A. Let us discuss about the position of particle at point P, which is x distance farther from the point O. So motion of particle under SHM. From the definition we know that acceleration is directly proportional to the distance. By removing the proportionality sign we get a proportionality constant, which is mu, and we take acceleration as negative as we take the velocity here in the opposite direction, which is negative. So we get x double dot, which is acceleration, is equal to v dv by dx, which is equal to minus mu x. By replacing the values we get v dv is equal to minus mu x dx, and on integrating we get v square by 2 is equal to minus mu x square by 2 plus c is a constant, integration so constant. At point A we get x is equal to A and v is equal to 0, which is the end point. So at end point v velocity is 0. By putting all these values we get the value of constants. The value of c we get is mu a square by 2. Now from the equation, by placing the value of c as getting 2 as common, so we get v square is equal to minus mu in bracket minus x square plus a square. The required equation for SHM we get is v is square is equal to mu a square minus x square, or we can written it as v is equal to plus minus under root mu under root a square minus x square. One thing to remember in this is when we have the motion A to O we take it negative, and when we have the motion O to A we get it positive. We will take it as positive. We have two cases here. First is A to O and second is O to A. So in this, by looking at the figure we note it, and the particle is moving from first it moved from O to A and then A to O, to and fro motion. Okay, so the equation we are getting for SHM is v is equal to under root plus minus under root u under root a square minus x square. So in first case when particle move A to O, in this we take it negative, the direction is negative, so we take v is equal to minus under root u under root a square minus x square. We can write v as dx by dt, so dx by dt will be equal to minus under root u under root a square minus x square. On integrating, dt is equal to minus 1 upon under root u under root a square minus x square dx. On integrating we get t is equal to minus t is equal to 1 by under root cos inverse x by a plus c2. Here c2 is again a integration constant, and at x is equal to a, t is equal to 0, we are getting c2, and the value of integration constant as 0. On putting all these value we get t is equal to 1 by under root cos inverse x by a. On simplifying this we get the equation x is equal to a cos under root u t, which is for the case 1 when particle move A to A. So this is the equation of SHM when particle move from A to A. Now we will discuss the second case. In second case, we are seeing when particle move from O to A. O to A. So in this we take velocity as the positive. V is equal to plus under root u and root a square minus x square. Similarly, by putting the dx by dt value of v, we get dx by dt is equal to under root u under root a square minus x square, and on integrating we are getting dt is equal to 1 upon under root u under root a square minus x square dx, and t will be is equal to 1 by under root sine inverse x by a plus c3. C3 again a integration constant. On putting the value x is equal to 0 and t is equal to 0, we are getting its value 0. C3 is equal to 0. By simplifying all this, similarly we get the equation x is equal to a sine under root u t, which is again for the case when particle move from O to A. So in both cases we see when particle moving from A to O, we get x is equal to a cos under root u t mu t, and in second case we are getting x is equal to a sine under root mu t. There are some more definitions which we need for in this chapter. First, the amplitude of SHM, which is the maximum distance from the particle from the center. It is denoted by A. So in this we have amplitude OA, which have the value A. Second is period of SHM, time taken to make one complete oscillation. Its value will be t is equal to 2 pi by under root mu. And frequency is the reciprocal of time period, which is the number of complete oscillation in the 1 second. So n, it is denoted by n, and n is equal to under root mu by 2 pi. So all from me. Thank you.